Welcome to all. Concluding part of the procedure. I already told, I stopped last time. Continue. See, this is already over. Don't write once again. See, this statement is already over. Because you wrote already. Compare mu with mu limit. Then last time you wrote case 1, mu less than or equal to mu limit. What to do? Singly reinforced, AST finding, simple, already over. Now, case 2, mu more than mu. I once again wrote here, see, factored Bm to be resisted by cross section, how much maximum singly can resist. Okay. Therefore, then cross section is to be designed as doubly reinforced section. Remember, you can refer IS code, page 96-97, full procedure is there. You follow that one. But there is one small mistake there, technical mistake. In YouTube, I don't tell it because this is universal. I do not want to highlight the mistake. Regular class I told what is the mistake. Not a mistake actually, the way they told that, it is not, I don't agree with that one. That is, they told there, see, briefly I will tell. Where the ultimate moment of resistance of section exceeds, sorry, it is not a ultimate MR. When the bending moment factored Bm exceeds, so by mistake they told ultimate MR exceeds. If MR is more means safe, why worry? So you should correct it. When the ultimate moment of resistance of section exceeds, you change it to when factored Bm for cross section exceeds. You change it. Okay. Now, doubly reinforced. Therefore, we have to find AST required and also ASC required. Sketch cross section showing both AST and ASC and D dash. Okay, now, class, very important. If this step is forgotten, you will have difficulty for continuation. One statement you have to write. Required cross-sectional area of longitudinal reinforcement means what? ASC and AST are calculated corresponding to a balanced section. So, now we reach the limit and going further. When you further go, you are using the limiting strength. So, XU equal to XU max. So, now onwards, everywhere XU is replaced by XU max. This statement you have to write. Okay, write it. Then, XU max by D is already known. Therefore, see, in the basic data, you know XU max by D. Take D that side, get the value of XU max. Then, first find ASC required. How? See IS code. Mu minus mu limit equal to FSC into ASC into D minus D dash. Actually, in the class, I will explain what is the meaning of this one. But for you know, because it will take some time. Because every concept I can't tell here. This is anyway, some people will tell, okay sir, given an IS code, happy. This is a given IS code. Or see, you can make out here. Mu is how much, suppose imagine, factored Bm is, mu is, just to teacher's instinct, 150. This is 100. So, cross section has resist 150. 100 is by singly reinforced section. Shortage is there, that extra is compression force into lever arm. Extra resisting capacity is the formula. Okay, now, FSC is, see now, make a note. In case of analysis problem, we call FSC as stress to be considered in compression steel. But now it's a design question. So FSC is design stress in steel in compression corresponding to a strain in compression steel epsilon SC of 0.0035. Earlier it was XU. Now anyway, our XU is XU max. Or refer IS code. They told XU max minus D dash by XU max. Substitute, get epsilon SC. Calculate. Substitute and calculate. Okay. Substitute and calculate, because this is going to be calculated value of epsilon SC. Now, 1 minute. Something I want to tell. This statement has got some meaning. Again, when you are not showing interest in the original under-reinforced section, I am not going to tell. If time permits or if I get the sufficient number of requests, all this concept, one long class around 1.5 hours, I will tell more and more basic concept. Very important for understanding. Okay, leave it now. So epsilon SC came. Now for epsilon SC calculated, get FSC. See, I will tell you here, sorry, I am not explaining even a very small part also, because so thoroughly considered earlier, so many example after example. See, first I explained in the class the concept, then numerical example only for FSC, then problem after problem for doubly FSC came. Therefore, I am not explaining, get FSC. See, class, note, same thing. Instead of stress considered, it is design stress. Okay. If you want FSC, you go back to in the title RCC class 42A and 42B. That is for the group. For general public, when analysis of doubly started, see, I told first I uploaded singly around 8-9 parts. Then I started doubly. I think total 10 parts are uploaded. There, part 1 and part 2 are exclusively meant for how to find FSC once you know ESC. Therefore, not ESC, epsilon SC. Earlier I was calling E. Okay. Therefore, this I will not explain. First of all, it is explained many times. Go back to what title is here, or part 1 and part 2 of the analysis problem. Work out that one, and then if you want, write once again. No, you write already over. Well, anyway, when I solve the problem, I may briefly explain. So FSC calculate. Okay, now get FSC over. Now last step now over. See, once that is over, substituting FSC, get, see, right here, mu known, mu limit known, FSC is just now known, D is known, D dash known. Substituting FSC, get ASC required. So now ASC required is over. Okay. Now you should calculate what is the AST required. I need once again full board. I will rub everything now. I will start here. Okay. Next step is I write here now. To find, next part, to find AST required. This AST is not single line post AST. I will tell you a note for you. AST required. This is next part. Okay, I will continue after rubbing everything. You write the systematic procedure, follow it. There will be no difficulty in future. Now, to find AST required. Just a minute. Not required for public. Those who are in the RCC batch. When I derived the basic equation for WIN post, if you remember, this is not for general public. If you remember, I considered two sections. One singly with AST1 and next additional ASC compression and AST to tension, and derived the equation. You all know it. That when at that time I told you this concept you require for design also. Okay, leave it. Now for general public, find AST required. That is called total area of tension reinforcement required. Means IS code is splitting AST into two parts, AST1 and AST2. Make a note. Some people for analysis they do this one. Outrightly wrong. 100% wrong. People, without thinking, someone will tell the procedure, they will follow it. That is their problem. Correct procedure, this you can do only for design. Okay. Now, total area of area. First time when I come here, just rubbed out. Total area. AST1 equal to AST1 plus AST2. IS code has given. AST1 is the area of tension reinforcement required for a singly reinforced section for mu limit. Now you know that this is what is given in IS code. You know, mu limit means when xu equal to xu max, means balance section. So indirectly they are telling this is the best version. Instead of IS code, this is the best version. AST1 is cross-sectional area of tension reinforcement required for singly reinforced rectangular balance section, that is for xu equal to xu max, not doubly, for singly. Okay, start. Find AST1. One of the option. Go back to singly reinforced section. Write equate resultant compression to resultant tension. At that time you write 0.36 when there was no ASC. 0.36 FCK BXU equal to 0.87 F point AST. Now what you do is this AST replace this AST by AST1 and substitute this XU substitute XU max or 0.36 FCK BXU max equal to this one. Or in IS code, expression is given in the beginning for singly reinforced. They given XU by D ratio. Use it. XU by IS code has given it. See, it is given IS code. XU by D equal to, they told, for a singly reinforced section. They told very clearly for singly reinforced. XU by D equal to 0.87 F point AST by 0.36 FCKBD. What you do? This singly AST is our AST1. Replace this AST by AST1 and substitute XU by D equal to XU max by D. Note, if you observe correctly, both are same. See here, D will get cancelled, cross multiply, both are same. What I will do is, in the class, because this is given in the IS code. When some formula is given in IS code, people want that formula. So, I will use this one. I will use this. Actually, both are same. Okay, note, both are same. So, AST1 is calculated. Now, lastly, you require AST2. Okay, I will do one thing next week. I will come here. Next. Now, find AST2. AST2. I will tell you what is AST2. That is, if you want technically to know what is AST2, additional cross-sectional area of tension reinforcement to balance compression force in compression steel, that is in ASC. That all I explained in the group, in the batch, I told that one. Here formula, or not required. IS code has a directly given equation. The IS code has given directly ASC, AST2 equal to, a very clearly given, FSC into ASC divided by 0.87 times FY. Anyway, IS code has given the equation. So, some will tell, sir, okay, sir. When IS code given, why should we bother? See, usual I am checking the cap. Oh, sorry. I not put the mic on. I forgot to put the mic on. Hope my voice is okay. I don't know now. I can't re-record it. So, little voice problem. So, I will do one thing. Because of I forgot the mic. So, I will explain once again. So that in case voice is not clear. AST required equal to AST1 plus AST2. AST1 is the area of tension steel for a singly reinforced rectangular balance section for MU limit. Or easy way to understand, it is the area of tension steel for a singly reinforced rectangular balance section XU equal to XU max. Equate CU to TU for singly. AST replaced by AST1, XU substitute XU max. Or use IS code. IS code for singly reinforced has given this equation in the beginning only. Use that equation where AST is there, replaced by AST1 and XU by D, substitute XU max by D. AST1 is calculated. AST2 is the additional area of tension steel required for balancing compression force in compression steel. ISCO directly gave formula, actually see, AST2 into this will give you extra tension force equal to compression force. Leave it. AST2 equal to FSC into 0.87 Fy. Right here. FSC known. Now ASC also known. Everything is known. Last step. Substitute. I should check the camera. Otherwise, sometime what happens is everything is over. Lastly, camera problem. Oh, no. Okay. No problem. Okay, I write here. Substituting. Find AST2, and then lastly find AST required. That is total right here. Total AST required equal to AST1 plus AST2 already given here. Over. Right. Therefore, all over now. Therefore, now we know how to find AST required for singly reinforced section and AST required and ASC required for doubly reinforced section. Anyway, remember, this is part 3. All these 3 parts write in a single stretch and make a fair copy, because part 4 I am starting numericals. Some will tell that is the most important, where these all I will not write. I will explain step by step. Systematically I will write statement applicable for the problem. Now 1 minute. I am going to my native place today. So today non-stop I recorded now. See, from night time I am recording class after class. I am uploading in stages, one after the other one. There may be a delay of some, I may come back after some 4-5 days. So meanwhile, these 3 I will upload one after the other one, daily one. Then there may be a gap of 1 or 2 days before I start upload part 4, which as soon as I come back, I will record here and upload part 4 and part 5, 2 parts. Both are numerical examples. With that one, this design part will be over. Okay, thank you. Go through thoroughly all these 3 parts and prepare a systematic procedure with you. Thank you.